Okay, hello everybody. This is the fifth and last session of the course. We already covered almost everything that there is to know about the syntax and semantic. Only remaining point, iterators and generators. We'll we'll cover those points today, and after that we'll get to a certain element of pragmatic ones, how to create in Python.
Jose, you're disappearing, or is it just me?
Excuse me?
The sound is disappearing from you, or is it my problem with the internet?
Jose's, I guess.
Let me get closer. Okay, I was telling you that the only thing that remains to be covered in the language are iterators and generators. And after that, we'll talk about the pragmatic, what to do to start a project, how to handle the code itself, some, I hope, helpful tips about how Python. Okay. The only aspect that remains to
the issues, I don't think it's with the distance to your microphone, but you're with your connection. I mean, you're constantly dropping words for me as well.
Exactly. There's a lot of hiccups here. You're right.
Okay, sorry. So I haven't changed anything. I don't have anything running in the background.
Are you on Wi-Fi?
Yes.
Well, don't be.
But I don't have a connection point here. Can you hear me?
Yeah, from time to time it's good, and then for other times you're constantly, there are hiccups, you're dropping words.
If I drop and get back in, I think that we are going to lose the session. So
yes.
What should we do?
Not always, because mine also disconnects and I reconnect like earlier when. But I think let's just stay, and if we don't understand something, let's ask, and that's it.
Okay, let's try to keep going, and let's see if we are lucky. Okay, the idea is that the last topic to cover in the Python, the language. I was watching recently that
iterators, right?
Excuse me.
Because we were not able to hear you. The last thing it's lacking to talk about in Python is, and then silent.
So we have a problem. So should I disconnect? Should I disconnect?
Yeah, of course.
Okay.
Let's try. Let's this.
Okay. Here I am again. Can you hear me better?
Yeah, so far, and it still says live, so it looks good.
Okay, and the connection is still live, so hopefully there's no problem there. Okay, iterators. The idea of iterators, already I saw that it seems that the new JavaScript version are going to include iterators. So I think it's nice that you know it here. so you can use it in other language too. We already have seen iterators in action. For example, we know that a list, a tuple.
Jose, can you share screen?
I think that yes, that will be very useful. Okay. The idea is that we already saw how iterators work indirectly, right? We know that we can use a list in a list in a for loop, and we get the elements. The same thing with a tuple or a dict, right? We also saw that we can do the same with files. So it's a pattern in Python. Also, we can use it here. In list comprehension. As we can see, Python allows us to iterate over a loop for certain elements like lists, dictionaries, tuples, and files. But the idea is that that's a more general feature. In fact, arbitrary objects can be used to iterate over them, and that's the iterator pattern. Do you remember when we saw decorators that the name decorator was used incorrectly? In this case, the name iterator, it's the real thing. This implements the iterator pattern. How does Python do that? Well, it uses what he calls the protocols. So an object implements certain interface, and if he has the right method, if he implements the interface, we say that it implements a protocol. In the case of iterators, the iterator pattern is divided in two protocols. The iterable, that it's an object that can be in a for loops or in a list comprehension, and the only method that it needs to implement is iter. Iter returns an iterator, the real thing, the object that is responsible of generating the elements that we will visit one by one. This method normally it's invoked automatically by Python when he knows that it needs an iterable, or you can invoke it using the predefined function iter. So an iterable returns an iterator, and the iterators implement, here there's an error, that is not the underscore next, but simply the next method. The next method returns the next element in the list, in the sequence, or if there's no more elements, it returns a stop iteration. One interesting thing to think into account is that since iterable and iterator are very simple protocols, normally they are implemented by the same object. So the iter method normally returns itself, returns the self object, the self variable, and this object implements iter and next. Right? Basically, this is all with iterators. But as you can see, to implement an iterator, you need to create a class because we are talking about methods of objects. So an iterator is an object, right? That's why Python created the concept of generators. A generator is a function that acts like an iterator. It's a normal function. The only difference is that instead of using return to return a value, it uses GEL. When Python sees a function that uses GEL, behind the scenes, it takes that function and make it a generator, but the idea is that it makes it act as an iterator. So the function stores its state. It's like a closure. When it uses GEL, it's not like return when the function ends and all the information associated with the function disappears. No. The state of the function remains, and when the iterator is called, and next time the function is reactivated until the function, the body of the function finish or it uses return. In this case, it's the same as the end of the iterator. So this is a nice way to return a generator. So for example, we can define a very simple iterator and say job 1, job 2, job 3. So we can use this iterator in an expression like this one. You see, the first time that the iterator, that the generator, because this is a generator, it's invoked, it executes this line and return 1. But since the generator hasn't been exhausted, the loop keeps going and it's invoked a second time, it's invoked a third time, and after that, since there's no more to do, the generator finish and return what it's expected of an iterator. Let's see it from other perspective. We can say that G equals to blank. That's the type of the G variable. It's a generator. Since it's a generator, we can expect that it has the next method, right? So if we invoke that method, we get the first value, second value, the third value, and a stop iteration. The error that is generated once there's no more element in the iteration. So in summary, we have iterators that allows to take any data structure and make it possible to traverse it using a loop, and we have generators that are an easy implementation of iterators. But it's more than that, because as you can see, this is a function that keeps its state. It's kind of a closure. So you can use generators to implement coroutines. So you can have functions that store their state, call each other, or are called for other code, and keep his state going. That's in an object-oriented language. You can do the same with objects, but it's nice to have this cheap version of doing the things. So are we right there, right?
But what I see is like function definition is the same. It's somehow handled
Yes,
in an unclear way.
it's very similar, but the difference is that instead of using return, you use YELD. And when you use YELD, Python knows that this function is in reality a generator, and it creates a structure to support it. So it wraps the function in an object, and as you can see, look how all methods it has. So this function is decorated and becomes a generator.
What will happen if you add a return with YELD?
There's no problem, because return here, it's an implicit return. So a return simply means that the function ended and the iteration ended, and the generators that wrap this function will return an stop iteration.
But it's also possible to use return to stop generating new values, right? If it's some kind of loop and then there is some conditional things inside, then you can do return and your generator stops.
Yes, exactly. A return ends the generator. It returns from the function, and once the function has finished, the generator rises a stop iteration. There are other interesting things that have been included in the generator protocol, that now you can pass information to the generator, for example, to modify the sequence of values. But we won't get into those details right now. The important thing is that we have those functionalities, and that functionality it's becoming more and more common in several languages, including Java, JavaScript, etc. So after seeing this keyword, we can say that we know everything we need to know, or everything that is to know about the language, the syntax and its semantics. So that part of the course is complete. Now we can go to the pragmatic part, that is how we program in Python. What's the best way to do it? What tips and tricks we can learn? Since all of you are in front of your computer, I will advise you to follow the procedure and the step that we are going to the commands that we are going to execute. Well, first a little bit of concept, because in Python you'll hear a lot, and you maybe already have used the words script module package, and maybe you have already heard X and Rails. Well, a Python script is a concept that maybe doesn't need a lot of introduction. A Python script, it's a text file that contains Python code that is executable, and if you are in a Unix environment, it must have the shebang, right? This is the shebang. Something like this, or directly the USB user bin Python. Right? Okay, and the idea of a Python executable, the Python script, is that it's a command. You can put the command in any folder. Normally, you would put it in a folder that is in your path, so you can convert it in a command. But there are a couple of problems with this approach. It's very simple, it's very easy, it's very quick. But what if your script requires a library? If it's one of the libraries that comes with Python, there's no problem. You can use urllib, the library for SMTP. Python have a lot of libraries. But if you use a library that isn't included with your script, that isn't included with the Python standard library, well, then you have to manually install that library, right? And if you copy this script to another machine, you have to copy the library in that machine also. So it's quick and easy, but the management and configuration part, you have to do it by hand. The next step.
Sorry, Jose, may I interrupt you?
Sure.
So you were saying that there's no package manager whatsoever in Python, something like a .json file, package.json file, that whenever you copy over the Python project from one environment to another, those we don't need to care about those dependencies. Then that package manager can handle everything for us. You know, like the NPM or a Bower manager.
Yes. Yeah. I understand. And we are going to that. Python have those package manager, and we are going to use it in a few minutes. But what I was saying is that the most basic element of the Python hierarchy, it's a Python script that is an executable, and that executable can be alone, but since it's alone, you have to make the support yourself. You have to install the libraries and so on. So this is an option for throwaway code. Like all the examples that we have done. For example, do you remember counting the words in Romeo and Juliet? That's something that can be perfectly done in a Python script. We don't need libraries. We use it a couple of times and then delete it, right? We are going to see how to add Python script to Python package in a few minutes. But for a manager, for example, for a sysadmin, you can write a Python script, only use the standard library, and you are fine copying that file in user bin, for example. Right? Okay, the second level in this hierarchy of Python code is a Python module. What is a module? A module is, again, it's a single file. It has the extension py, the Python script doesn't need the extension pipe. It only needs the shebang, unless, of course, you are working in Windows. When you are in Windows, you need the extension to associate the interpreter. But a module, it's a file that contains Python code. It has the Py extension, and it's intended to be used as a library. So the idea is that you can import a module and use their function, their objects, all the data that is defined there. A Python module needs to reside in one of the folders where Python looks for the modules. Normally, those are system dependent, but you also can add folders to the Python path variable. And again, it's the same. Here we are talking about the basic level, and in the first interaction of Python, when it doesn't have, it was the same. When you wrote a module, you have to copy that module in USR lib Python site package and put your module there. And you have all the problems that we already described, right? Okay. The next level, it's a package. We see that a module is a file, and eventually, when we are writing code, using a single file is problematic. So we want to take our library and use several files to spread the code to make it more manageable. And that's what a package is. A package, it's a folder, but look at this. The folder needs to have a file with this name, underscore init underscore .py. That's what indicates Python that that folder, it's a package. A package, it's like a module. It's a folder that contains code that can be imported by Python. Again, this folder needs to be in the Python path. So again, you have the same problem that you have with modules and with the script, that you need to copy that folder in a place in Python path, or add the path to the package in the Python path variable, right? So until this point, all the management of Python code is done by hand. One interesting thing is that when you import a package, let's see if I have an example here. Okay. Okay. For example, this path that you see here, it's a path to a folder, and that folder is a package, as you can see here. If we see that file, okay, this has a lot of things, but let's create our own package here. For example, let's create a BLA package. At this point, BLA is a package. And since the current directory is in the Python path, I can say import blah. That does blah contain? It doesn't contain anything really. The name of the package, the name of the file, and then the documentation and the path. That's reasonable because our init file is empty. I can add a module in this folder, for example, our module sum. And how do I use that module? I can say, for example, import blah sum as you can see, I have a blah package. That blah package has a sum module, and that sum module has a sum function. Of course, I could say from blah sum import sum. But let's see something interesting. What happens if I start again and I say import blah? How can I access my sum function? Any guesses?
Well, you have to import it again somehow.
Well, I import the package blah, but as you can see, the package blah doesn't have a sum module. And that's right, because the package is this. The package is this file. It doesn't have anything. So when
You
I
have
say,
to add an entry in the init file, I guess.
exactly, that's an option. When I say import blah, I'm importing the content of this file. So if this file is empty, and it could be empty because we use it as a marker of that this directory is a package, then I don't import anything. But his mere presence indicates that blah is a package and that I can import modules from that package. So you have these two options. Use the init file simply as a marker, or you can say here, for example, you can use the dot in this way to indicate that the path is relative to this file. Now I say import blah. As you can see, importing a package, it's equivalent to import the init file in that folder. Only that. But the important thing is that the init file indicates Python that this folder it's a package, and that this folder contains modules and that we can access those modules with import. It's the same. Okay. So, Python script, executable code, a Python module, a file intended to contain the function, object, etc., a Python package, a folder that contains modules. But we already seen that these three elements are only to contain code. We have the problem of dependencies. We have the problem of installing the package. So until this point, we are forced to do all the installation and all the configuration and all the setup ourselves. That's why the next element are known as X, Python X. Python X, it's a way to configure package modules script to indicate all the characteristics and to make them installable and to handle the dependencies. So when we write a project, of course, we need to write package modules and script, but we will use X to handle what are the dependencies of the package, to install the package in the system, and so on. And Python will is just the newest version of Python X. It just adds a little bit of metadata. It uses new structure. And answering Eduardo's question about NPM and all that, yes, that's the X is the real equivalent to JavaScript package. And we will see in the next slide what's the equivalent to NPM. But we are going to work whenever we need something more complex than a simple script, we are going to work with X, right? And here comes the NPM. What for JavaScript is NPM, for Python is pip. Pip is the command used to install package. It installs the package and all its dependencies. What else? And of course, Python has a repository of a Python package that is named PyPy, or as we say in Spanish, PP. So also pipe, you can configure it to use your own internal repositories. If you are using the latest version of Python, I think it's Python 2.7.10 or Python 3.5 and on, you already have pip in your system. Please try in your computer and verify that you have pip. If you don't have it, please install it. You can use sudo apt. If you use Ubuntu, the name of the package is Python pip. So you should say sudo apt install Python pip if you don't already have it. Or Python will. All of you have a pip installed. How many of you have already pip installed?
I have it installed.
Okay, Alex, Eduardo.
I have it.
Perfect. Victor and Raluca.
No, I don't.
Okay, if you can, please install it during this moment, because we are going to use it in the rest of the slide. So with pip, you can install package. If you have it valid, you can, for example, install this library. It's very nice. It's to handle HTTP request, web HTTP, FTP, etc. It's very nice. It's more nicer to use than the library that comes with Python. So you can install it. You can use a upgrade the version of the package. You can install certain version of the package, or require that it will be bigger or lesser than one, or you can install a Python package. With this, you solve one problem, that is how to get Python code, right? With this command, you don't have to browse, to search the web and look for package, because most of the packages are in the Python package index, right? I think that you can even use URLs here and it understand, for example, GitHub. So you can even use other sources if I'm correct. I'm not sure. Okay, but this install the package. We'll see that we have still a couple of problems to have a healthy development environment. One of the problems is that, as you saw, you have to have root access to install, for example, pip. And when you try to install something, okay. You also need a root permission, because the package by default will be installed in a system folder. So that's one of the problems. The other problem is that, and that's a problem that you have in all the popular languages that have libraries installed with the system, and is that the library that is in your system could be old or can be upgraded independently of your work in your project. So if we look, all the libraries that have Python, as you can see, it has a lot. Maybe the system administrator of this machine installed the Jam library, and I'm using in a project, and 1 week he installed a new version, and the code that I was working on stopped working for that reason. Or maybe I need the newest version, and the system has an old one. That's the kind of problem that you have when you have a lot of libraries handled by this operative system. So to solve that problem, there's a package called virtualenv. Virtualenv is used, as its name indicates, to create a virtual environment for Python. When you create a virtual environment, you basically are creating your own Python interpreter. But it really is, it's the same interpreter that the system already has, but your interpreter is configured to use libraries that are in your folder, in a folder that you can control. So this Python interpreter doesn't have access to the to most of the system libraries, and in that way you are protected from the sysadmin upgrading, deleting libraries, and you can install your own libraries. So the only thing that you need is that the sysadmin install a virtualenv. Of course, I already have it installed, but you see, when you are working in a Python system, you must request your sysadmin that it has installed pip and virtualenv. After that, you can work on your own. So what's the idea of a virtualenv? How does it work? The idea is that you can say things like this. You can create a virtualenv. Normally, I call them in this way, with the name of the Python version. When you do that, the virtualenv creates a folder. In this folder, you have the Python interpreter, the pip command. This is the old. This is basically the same as pip, but this is used. This was used some time ago, and it still is hanging around. You have the new version of pip, and you have your library. When you have all the libraries you have access, plus the new thing that you have installed. So you have control over your Python environment. To work with Python environment, you need to activate it. If I question, for example, what Python interpreter I'm using right now, I'm using the Python that correspond to the system. To activate the virtual environment, you need to load these files. If you are using Bash, you execute this command. Since I'm using the fish shell, I use this one. But, this one has a problem. So because I need the latest version of fish. So let's use Bash. As you can see, the virtual environment is now active. So if I ask which Python interpreter I'm using, you can see that it's no longer USRV in Python. I'm using my own version of Python, and I have access only to these libraries here. But the good thing is that now I can install libraries without being root, and I have control over these libraries. So I don't need root anymore. So this is the idea with the virtual environment. Of course, there's still a problem here, and is that I'm still installing the dependencies manually, right? If I have a project that requires request Panda, then I'll have to type all the dependencies here. But that's why they created a package. Okay. And this is what we are going to talk now. The idea is to create, when you are working with Python code, with a project, a non-trivial project, you should organize your code using a Python egg. And the best way to do it is using, for example, these templates. If you install these libraries, you can easily create a template for your project. So let's do it. Of course, you can also do it by hand, but it's a little bit boring. This package here, Mr. Bob, it's a template generator. What would be the equivalent to in JavaScript world? I don't remember. But okay, but for example, you can do this. You can create package name test maths, and very similar to npm, it will ask you for a series of questions. This question here, the distribution name, the package name, you will see let's create a package name test inside a package name maths. That's very nice, and I will recommend you to all your package be called either maths.blah.foo or vice versa. You can see. As you can see, it created a folder that contains the basic setup for your package. The interesting part happens here and here. In source, as you can see, you have your test package that contains your match package, and here is where you start with your code. Of course, this is just a template. You can delete this. So you put your code here. Here you create your modules, your sub-package, and so on. But the information of the package is in this file. There's a lot to say about that file, but as you can see, it's almost self-explanatory. The only boilerplate is that you import this function setup, and then you simply declare the attributes, the name of the package, the version, and so on. The interesting part happens here. Here is when you declare your dependencies. So if you need, for example, request, you add it here. And here is where you stop to worrying about getting manually all your dependencies installed. And of course, you can indicate the version and so on. Also, here in entry points or in scripts, you can indicate that you have a script that you wanted to be installed in a path where you can execute it. Or you can indicate, for example, that you have some data files that you want to copy outside of your package, or that you have data that you want to copy inside your package. So, you can indicate extra dependencies, for example, for development. You want to use a test library for unit tests, you put it here. So when you install the package in developer mode, you get those tools, but when you distribute the package, those tools don't go. And you can indicate, for example, if this package is part of a framework, you can put here hooks, so the framework knows, for example, that this is a plugin, things like that. Right. That's the idea. The last element is with this, you have your package, you have your dependencies, and you even have some control about your version. But there's another tool that you can use that is called a build out, that does something similar to virtual environment plus the package, and it's that it allows you to fetch all the dependencies of your package, build them together, handle the version that you are using in your project, and store it so you can reproduce it in another machine, because here you have to indicate the versions by hand. So with the build out, the idea is that you've been able to reproduce the exact same environment that you have in your machine in other machines. So, but this is a tool that I don't know, for certain reasons, a lot of developers don't use. Most have enough with the virtual environment and the package itself. And finally, commentary about some interesting libraries that you can find in Python that could be very useful in your work. For example, the shu library allows you to execute shell commands as if they were Python functions. So if you need to interact with the system, this is very nice. Of course, there are libraries in the standard library that allows you to execute command, but these libraries make life very easy. Or beautiful SOAP and LXML that allows you to parse HTML and XML. SQL Alchemy, that is one of the most popular object relational mappers of Python, and so on, so on. Maybe the other tool that I want to talk to you about is this one, Jupyter. Jupyter, it's a project to have a Python interpreter inside a browser. And you have what is known as Jupyter Books that are pre-recorded sessions of Python. For example, this is a session I was working on 15 minutes before starting the course. As you can see, I can add text, but the interesting part is that I can add Python code here, and this Python code is executed and its result is shown in the page. For example, I can run all the cells here, and as you can see, it executed all the Python code, show the result, and it's very nice. Some organizations use Jupyter as a substitute for application even, because what could be a Python script isolated in a folder, here you have access to it, you can interact, you can modify it. And the most interesting part is that it's very powerful. So, well, of course, you can edit HTML, but you can import libraries like the ones that are used in science, and you can, for example, Priya, it's sad that he isn't here now because I know that he's working with pandas, and here you have a pandas cheat sheet that is interactive. You can play with this live and get immediate results. If you have ever used Mathlib or Matcat, this is replacing those applications. This is even replacing other tools like R, for example, for data analysis. Look, for example, to this one. Okay, this is an image, and this is an author of a comics. This is his style of drawing image, and someone thought to make this style, apply this style to real plots. So as you can see, this is a real plot generated in this page. Well, no, this is the image. We will see the plot below. But NumPy Lab Sizelab and Matplotlib are very powerful libraries to handle mathematics, statistics, and graphics. And it's so powerful that you can configure to make this. You can make the graphics looks like as if they were drawn by hand. Yeah. And as I told you, there are certain organizations that use Jupyter notebooks as executable as a script, and you can use it, for example, to make a dynamic request and allows not so technical users to be able to do certain things with programmer. So this covers all the material. Maybe we should take a break and return for some simple exercises.
Jose, talking about materials, I think Haluk already sent a link, but I don't, I missed that link. But you're gonna share these materials that you prepare for the course? Okay.
Yes.
The PowerPoint. Okay. You send. I'm not. Yeah. Is that already right?
Yeah. There are in my Google Docs. So
I will make a Confluence. No, don't do that. I mean, you can do that, but please create a in Confluence in our space, in the DevOps space, and then I will add also the videos there.
perfect. Okay, so see you in 5-10 minutes.
Okay.
When you're ready, say yeah. Are we ready? Are we ready?
Yeah, I'm here.
And Eduardo, Raluca, Stefan?
Eduardo is not here yet. Victor is out of this chat.
Victor is looking into that issue together with Dimitri, the one that we had yesterday. So he won't be back for the practice. So
Okay,
all we have to do is wait for Eduardo.
perfect.
Let's start because we don't have much time, I guess, anyway.
Okay. Well, the last thing to do in this course is more than a problem as an exercise is to let your PCs ready to program in Python. So the idea will be to install pip if you don't have it, install virtual environment, make sure that you know how to create a virtual environment, how to create a package. So that's what we're going to do. The goal is to create a Python egg that install a script, but in a same Python environment. So we need a voluntary. Someone choose randomly.
I can be volunteer.
So please share your screen.
One sec.
here we are going to work more with the console. And I know that you already have installed pip, but let's try to install it again just to record the command.
In my previous company, pip was personal improvement.
It's okay.
Like this, right?
Yeah, and it's a
It's already there.
but it's apt get apt get.
In Ubuntu 16.04, it doesn't matter apt or apt-get. It's the same, or not the same. But apt is more human friendly.
But oh yes, it says that it's already installed. We
Yeah.
already know it. But the idea was simply to have the command there. Okay. The next step, and this is maybe the last one to be typed as root. Install another things like root for commodity. It's to install a virtual environment. That it's a Python script.
But Python script.
Yes, a Python egg.
So how do we do Python?
It's with the pip command. Pip,
Python.
I cannot.
I'm still sharing my screen.
Okay, yes, but okay.
Can you see it?
Yes, almost. Okay, much better. Okay, but yes, the command is simply pip.
Simply pip.
So, and pip install. Virtual env, exactly. Okay. Are you root, Alex?
What sudo? It's the same response requirement already satisfied.
Perfect. You already have installed it. We usually are going to install as root those tools, those libraries that doesn't change a lot. For example, another tool that we could be interested in install from everybody is Mr. Bob and Bob templates. This one that that I sent in the chat.
Should I install
can-
it also with the pip?
Exactly. You can install it globally, or you can install it locally. For purpose of this exercise, we can do it exactly globally. Mr. Bob is it's to create a Python folder templates used to create a Python X, and this other
Something with Bob template.
are you using Python 2, right?
Yeah.
Okay. The name is templates. It's Bob templates. I see an S.
Mm-hmm. Yeah, done.
Perfect. Exactly. Okay. As I said, normally we only use sudo, we only use root to install the basic libraries, the ones we want to share with everybody. Once we've done that, we create normally one virtual environment for us as user. We don't need more than one, but we could, if we are paranoid, use several virtual environments to different projects. So we are going to create a virtual environment. And the command is virtualenv.
So it creates a separate directory for it?
It creates the directory for you.
So the command is virtual what?
And the name of the folder that you want.
Like that.
Virtualenv has a couple of options if you want, for example, to copy all the libraries or begin from zero, but normally the default options are fine. Okay, that's the idea. We have our virtual environment. Now we need to activate it. Of course, we need to activate it every time that we begin to work on it. And when we finish, we deactivate it. And we activate it sourcing a file in the shell. That means to use the command, the dot command or the source command. So dot space and the path to activate. And of course, you have to use the right activate for your shell. If you are using bash, it's activate simply. Perfect. The VM27 indicates that in fact you are using the virtual environment. You can test it by typing which Python. And we see that you are using not the global Python, but the Python that lives inside your virtual environment. When you finish working in your virtual environment, you can type deactivate.
Yeah, I'm sharing screen.
Yes. Okay, so we have our virtual environment. We have our Python interpreter and our own library, so we can begin to work here. And the thing that we need to do is create a package. For example, create a Python package. Yeah. And we do that using the command that we see. Mr. Bob, then something like this. Mr. Bob, or the name of the package and the name of the template that we want to use. I advise you to use, since you are going to create, hopefully, a lot of package formats, that you use the prefix max in all your package. So that's a good one. So, exactly, the package name is the real name of the package. The other one is the name for which it will be known in the Python index.
What is shell command?
Shell commands, We will create a shell command for this exercise, but we will leave this empty. A shell command is a Python script that will be executed. So, but no, leave it empty. We will do it by hand. Nose-Test is a popular testing library, but there are several libraries. For now, we can say false. So, Sphinx is the documentation that Python uses. If you are going to create a package with documentation, I recommend to use Sphinx. The SCM, you can use Git, and it will create for you a default Git ignore and all that. And we are done. You have your first package. So we can please give an ls, and let's see. Okay, and let's move to the package. Okay, as we've seen, the source code will reside in the source directory, right? It creates a boilerplate inside source math test init. We can delete that, or we can empty that file. And yes, we can make things simple. We only will add a library with the old friend, the sum function, and we will create a script that import that library and uses it. So step number 1, let's see the content of source math test. Okay, let's see what that init has. As you can see, it's a default content. We are going to delete everything.
Everything.
Yes, maybe only the first line. It's nice to have that line in all our Python source code, the one that indicates the character code used. But delete also math test. Yeah, only the first line. Okay, we don't need anything else. Okay, with that, our source math test folder, it's a package. So we can create a module there. So let's create a module, let's say arithmetic, and inside arithmetic, define a sum function.
Okay. Like this, okay?
Yeah.
1 second. I need here to specify hashbang function.
Okay, the shebang, it's not necessary for modules. For Python script, it's required, but for a module, for a library, we don't need to put it. It'd be nice to put the Unicode screen, but since this is an exercise, we can omit. So yes.
To put what?
To the comment screen that indicates the Unicode type use. Perfect. So we have our, no, we don't need anything else there. We have already a package, MathTest. We have a module called arith, but we don't have the egg and we don't have any connection with that code and the Python interpreter. The MathTest for now is just a folder. It doesn't have any relation with the Python interpreter. So the next step is that we are going to install this package in the system. We could use, for example, for all those purposes, is the Python, the setup script. For example, type Python setup and minus help.
Python what?
Setup.py, that is the file that...
sorry, what's again, Python?
Setup.file, that is the file that contains the information of the setup. And minus help. Yeah, as you can see, with this script, we can create the egg properly. One of the most interesting uses is while we are, of course, we can install the package, but since we are developing the package, when we install it, what we are doing is to copy a version of the current package. And in developing, that's very inconvenient because we need to uninstall and reinstall with every change that we do. That's why setup has the option develop. So if you type Python setup develop, what he does is that it creates a symbolic link to the package on Python. So now it's like we have the package installed, but we have the live version. So every change that you do, you can see it in the system, right? And now, if you go, for example, go a folder up, and if you use the Python interpreter, now you can import the package MathTest.
Right?
No, import math with space, exactly. Of course, that package doesn't have anything, right? You should import the package MathTest arith, or even the function. In this case, will be from MathTest arith import soon. Okay. And the other thing that we can do is that we can create a script and install the script. So let's get outside the interpreter and go back to the package. Okay. You can create a script, simply a Python script to be executed. So you can, for example, create a script folder. I don't know, wherever you like, for example, in source, or I don't know if you prefer the root of the package.
What's the best way? What's the common practice?
Well, for me, since it's source, it could be in source, but not necessarily inside exactly at that level. A script.
They're still
No,
sharing something because I'm not able to. Okay. Are
exactly.
following along?
So we need to
Yeah,
just hold
it's a
the script, right?
Yes, and inside that folder, you can create a script. And let's call that script exactly sum without extension. This will be a Python script, so we put the shebang and we import our library and we use it. So the shebang is exactly, and we are going to import
Like this.
exactly. And now we can use it, for example, make a sum and print a result.
Sorry, what? To execute sum or what?
Yes, you imported, but you didn't did anything with that. Let's make a script that make a sum and print something. And of course, since that's a script, it needs to be executable.
So now we need to execute it.
Now we need to, the idea is that we want that the package install that script. And for that, we have the scripts option in the setup.py file. So yes, you see the setup function that it accepts a lot of parameters. One of the parameters that it accepts is scripts. You can add it.
Sometimes see it. Package. So do I need to add scripts?
Exactly. And scripts is a list with the paths of the scripts that you want to install.
And by default, I'd like to install
Yes, you want to install source / script. Notice that this is only for the script. The package was already installed. Right? Perfect. And now you can run again the setup develop, for example. And now the sum script should be in your path, well, or at least it should be in the bin folder of the virtual environment.
Yeah, there is a sum in the folder.
That's the way on which we control the installation of a script. In the same way, there are ways to, for example, install data files, but inside a package or outside the package in the system, in etc., for example. And let's go back one moment to the setup file. We already see that it has a section install requires, and there we can add any dependency that we are interested in install in the setup function.
Which one? Or
no, look in the setup function below that. Yeah. See, install requires. Yes, you can add there, for example, request or Panda or any library that you're interested in. Exactly. And again, if you make the Python setup develop, it will fetch all the dependencies. So now, if you see in the virtual environment library folder, no, this is not a binary. It's a package, so it should be in the library folder. Exactly. Probably it'll be in side package. Can you see it? I can see a little bit.
213 here.
Exactly. Of course, you can indicate the version of the library in the setup file, and I think that's all. That's the way we develop in Python. And since this is your last comment, the last thing that you should do is to deactivate the virtual environment with the deactivate command. No, the command is deactivate.
Okay. Do you need to specify the name or just like the...
No, it knows. And if you ask which Python, now you get the version of the system. Perfect. Well, and with that, I think that we conclude our Python course. This class shows the procedure you should follow in your day-to-day development. So thank you very much, guys.
Thank you very much, Jose.
Thank you,
been-
Jose. It was nice.
Thank you.
Yeah,
Thank you.
it's been
And
awesome.
see you later. Bye.
Thank
See
you.
you.
Bye.